Welcome to my CIS192 final project. Here's a preview of my README. So for my project, I did an analysis of a data set from like the website wish.com. Specifically, the data set had a bunch of like summer clothing products. I'd originally found this data set when I was doing my CIS545 project because I thought like the titles of the products were really cool. Sometimes it just seems like there was like a bunch of like adjectives and nouns thrown together as a description. But when I was doing that project, I didn't really have like the NLP tools to be able to do like the analysis I wanted, and now I do. Yeah, so I focused on like NLP analysis of the titles and like training a model to try to predict the rating based on like all the different parameters that are in the data set, as well as some ones I added after doing like the NLP. Yeah, here's a link to the data set. So a quick like walk through my requirements at the beginning. First requirement, I have a class called product. I overrode some like magic methods like int, length, string, and stuff that I use like in my NLP and for debugging purposes. Some of my first party packages are RE, like regular expressions, and date time, which I use to like either like parse through the titles and remove certain things, or like convert columns, like date columns, to like a date time format. I use a lot of third-party packages like pandas, NumPy, Seaborn, Matplotlib, Markovify, sklearn. I've commented my code and left like markdown text cells throughout. This is my README, and I'm going to include a link to this video with my Gradescope submission. You basically just run it as you would any other Python notebook. I recommend using like Google Colab, which is what I'll walk through now. Yeah, so here's my notebook. I have like cells explaining what everything's doing. Some of these cells might take a while to go through. You can feel free to skip through this video if you have to. Yeah, so here's some of my third-party, first-party libraries. I also use Spacey. I forgot to mention that in the README. So now we'll download the data set. And we'll load it into a data frame. So over here, you can see like the different columns that come with the data set, like the title in whatever country it is. Some of them are like from France or like Spanish-speaking countries. Original title in English, price, retail price, which is like what the product is like supposed to go as, and this is like kind of supposed to be like a discount. Yeah, so a bunch of like data regarding that product. So yeah, here's just looking at the types. I'll go through these kind of quickly. Here is where I use like the date time library. Yeah, so this is just basically like data wrangling, filling NAs and stuff like that. So the first part of my project is like natural language processing analysis. Here's my product class that I mentioned in my README. You can see like I overrode size of int, which like gives the ID and string. Which I used later on when I was like actually tying this to the data frame and like adding columns. Yeah, I used Spacey to help like tokenize. I ended up not doing sentiment analysis, but I did do some string similarity. Yeah, so here's my product class. It has like other functions as well. To like do like analyzing what like part of speech each like word in the title is. Yeah, so here's where I actually like convert like each of the like entries in the data frame to like a product class instance. And here I just have like, I've printed it out, which required like overriding of the string method. Here's some samples of like titles. So one of the first NLP things I did was like fake title generation. I had this idea because I was just like reading through some of these titles and they seemed so like incomprehensible at times. And like, it seemed like very easy for an AI to like just throw some random words together and have it look realistic. So I used Markovify to like generate fake product titles. Like over here, we'll see, yeah, muscle tops best tank. So just like a bunch of words together. So I actually like showed a bunch of these fake titles and a bunch of real titles to my friends and had them guess like which ones were real and which ones were fake Wish.com products. Here's just like the ones I showed them. And like actually they had like 11 wrong guesses and 8 correct ones. So I guess like these AI generated ones seemed even more Wish than the actual Wish ones. Yeah, I also made word clouds of like most common tokens based on like the tokens in my product class. Yeah, so like a lot of like plus size women's fashion, short sleeve shirt, things like that. And I also mapped out the tags. So each entry like has a tag column, which includes like a bunch of like tags related to that product. And I do all of this parsing of like the tags and everything in my product class. I can scroll back up to it. Yeah, up here in the init method. Yeah, I just did some additional data analysis out of curiosity to see some like averages. So I looked at like average ratings here, an average of like each number. A lot more 5-star, which is very surprising for Wish because it's kind of crappy. I also looked at the difference between like the listed price and the expensive retail price that they give. So the average discount is like 26%, which is a lot less than I was expecting. I was expecting them to like sell things for $1 and like say that it was like supposed to be 100 or something like that. Yeah, so the second part of my project was related to like machine learning. So here I just wrote a bunch of functions which I'll use like in conjunction with the apply method that Pandas has. These functions will basically like use the functions in my product class to count the number of adjectives in a specific title using like spacey and like nouns, verbs, and entities. These might take a while to run, so feel free to skip ahead. This one is going to like add a column in products.df that corresponds to the number of adjectives. And I've sorted them by like most adjectives, least adjectives. So you can see these have like 6, a bunch of them with 6, and like the lowest ones have 0. I did the same thing with nouns. So you can see like the top ones have like 13 nouns, 11, 10. And with the verbs, verbs was a lot less. Yeah, with only like the top ones having 3 verbs in them. And then the last one I did was entities. So like I figured I'd add this one to see if like a certain country name would like cause a certain product to like have higher ratings or lower ratings, or like a certain company name. Yeah, so there's a lot fewer entities than like nouns, for example, but still a good number. I also added in a feature corresponding to like the price divided by the retail price, again with like the whole discount idea I was saying. So we'll add these in. So you can see like the highest discounts, or the biggest discounts, so like the lowest price percentages, or like actual price over retail price is like 3%. So like huge discounts going on. Yeah, so the way I did like my machine learning model is I added like a label column corresponding to whether a rating was above average or below average. So I had like 2 classes. Yeah, you can see like the average rating was 3.8, which is like kind of a lot. Yeah, I guess not a lot on a 5-star scale. So then I dropped unnecessary columns and I just kept like the numerical ones. Yeah, and I created the features and labels data frames. Then I plotted a correlation matrix to see like which of my features were most correlated. They actually weren't very highly correlated, especially not as much as I was expecting. I figured that like the number of like adjectives, nouns, and verbs would be highly correlated with each other, but not that much. The most was like rating count with like number of units sold, which makes sense. So I figured since there was like this correlation here and a little bit over here, I would see if I needed to do PCA. It seemed pretty okay, like I didn't have to. I ended up doing it anyway, just capping it off at 11 to make everything run faster. Yeah, so I did PCA here. And then I tried out a random forest classifier. Spoiler alert for the accuracy there. Accuracy was very, very low compared to what I was expecting, just around like 61%. But yeah, like even that I think is an important result because it shows that like the rating has a lot more to do with like other factors like actual quality, like whether things were shipped on time, than like just the title, anything you can get from like the title or these other like parameters. I was expecting like the merchant rating and like merchant rating count to have a bit of more of a role in like being able to predict which ones are like higher rated and which ones are lower, but it turned out that it wasn't much better than randomly guessing. But yeah, this is my project. Hope you liked it. I really enjoyed the course.